1.
Welcome back to Chapter 8. We're on Lesson 3, Functions and Equations. Today we're going to learn how to write an equation to represent a function, and we're also going to graph a linear function. So this is our table of inputs and outputs. Somewhere in here we're going to find a rule, like what is going on. And remember, we look at our input first, which is x, and then that we determine from x how we got to our y. So how did we get from 1 to 9? Is it the same thing? I can see we're either going to multiply by 9, 1 times 9 is 9, or we can add 8, 1 plus 8 is 9. Let's check that with our second number in this series. So 2 times 9 is 18, that looks like it works. 3 times 9 is 27, 4 times 9 is 36, and 5 times 9 is 45. So I just found my rule. The value of the y, how did I get these y's, is equal to 9 times the value of x. So again, from 1 to 9, I had to multiply by 9, and that works for every one of these in this series of numbers. Okay? So if the value of y is equal to 9 times the value of x, my equation is always going to be in terms of y. How do I get to y? What did I have to do to that x? So y equals 9x. That is my equation. So I'm going to put this into my input-output table, and we're going to see how this rule works in this table. So my input is x, so you can see all my x's here. I will write in all my x's first. 1, 2, 3, 4, 5. I know my rule now, I figured it out. The rule is 9 times x, or 9 times whatever the value of x is assigned. So in this case, x is equal to 1, so I'm going to take my 9 and multiply it by 1, and my output is 9 times 1 is 9. The next one, if I input 2, I will multiply 9 times 2, and 9 times 2 is 18. That's my output. If I input 3, 9 times 3 is 27. Input 4, 9 times 4, whoops, did that backwards. 9 times 4 is 36. And finally, if I input 5, another word for my input is my independent variable. My output, or my dependent variable is, whoops, this should be 5, is 45. So remember, this is my independent variable. It's whatever, independent, and this is my dependent variable. So the y depends on whatever the x is. I could say, well, let's let x be 20. So what would be that 20th output? I would have to do 9 times 20, and that would give me 180. So I could put these in any random order I want, but I always have to follow this rule for my output. Now we're going to go to graphing a linear function. So I just figured out the rule, which was y equals 9x, and I want to graph that equation. So I'm going to use my input and my output values. Those become my xy coordinates. So when I was doing my rule and doing the function table, I can take my x, which was 1, and my output 9, and graph it here. So I'm going to go over 1, because that's my x-axis, and I'm going to go up to 9, that's my y-axis, and I'm going to graph that point, 1, 9. Where do I get my next coordinates? I go into my function table, and I look at the next one, and I'm going to graph 2 as my x, and 18 is my y. So over 2 up to 18, that's 218. Okay, my next one is 327. I'm going to grab the other one, 436 and 545. Now I have all these coordinates I could graph. So 327, 436, and 545. Okay, and remember why this is called a linear function, because this function here forms a line. And if I were to graph this line, I just graphed it, but now I'm going to connect the points. You can see that the points form a line. And that's why it's called a linear function. I want you to practice this one. Write an equation. I have my input and my output values. So remember, an equation is always going to be expressed in terms of the y. So how do I get to this y? I have to start with my x and see how I go from 1 to 16, 2 to 32, 3 to 48, and so on. We should see the same pattern for each of those. So I can see if I start with a 1 and the number goes bigger in my y, I'm going to either multiply or add. So I'm going to try multiplying by 16. 1 times 16 is 16. 2 times 16 is 32. 3 times 16 is 48. 4 times 16 is 64. And 5 times 16 is 80. So I just found my rule. I multiply